Hi, this is part 2 of filling out your study guide, key concepts number 3 and 4. So number 3 is all about writing rules or equations for functions, for piecewise functions. Okay, so I am going to color code this so we can clearly see the 3 pieces of this piecewise function. We have a horizontal line here, some sort of negative linear function here, and then finally a positive linear function. So let's begin with our first horizontal function. This is, we'll just call it line 1. And this is a horizontal line, so it has no slope. And if we were to continue, if we were to extend this horizontal line past its domain, we would see it would pass through the y-intercept of 2. So horizontal line passes through the point 0, 2. The equation for this horizontal line is going to be y equals 2. Any horizontal line is always y equals something. If it was a vertical line, it would be x equals something. So line 1, y equals 2. Okay, line 2 is going to be a little bit more complex. Line 2, we have to find a slope and a y-intercept. So the slope of this line, we can pick some points and count, do some rise over run. So it looks like no matter where I choose on the line, I'm going to be rising by 1 and running by 1. And because this line has a negative slope, it's going down when we look at it from left to right. This slope is going to be negative 1. So down 1 over 1, down 1 over 1. The y-intercept of this function looks like it crosses the y-axis at negative 2. So what's the equation for a linear function with a slope of negative 1 and a y-intercept of negative 2? I'm going to plug it into y equals mx plus b, where m is slope and b is y-intercept, and I'm going to get y equals negative 1x minus 2. So in math, we don't normally write negative 1x, we would just say negative x minus 2. And that is our equation for our second line. Okay, the third line is a positive linear function. It has a positive slope. And that slope looks like it's going to be also 1. So if I choose 2 points, the run is 1, the rise is 1. 1, 1, 1, 1. And it's going up. When you go from left to right, the function is increasing. Therefore, the slope is positive 1. And the y-intercept is not clear, but if you take a ruler or you kind of use your eyes, you could see that if you were to extend this function so that it had a y-intercept, that y-intercept would be at negative 6. So if this function went beyond its current domain, the y-intercept would be negative 6. The equation for that is y equals 1x minus 6, otherwise known as y equals x minus 6. And that is our the equation for our third line. Okay, so now comes the piecewise function part. We're going to be putting all of these equations into some sort of function rule. The general form for this rule is y equals weird bracket. We're going to have an equation, and then we're going to have a domain, and I knew that this is going to have 3 pieces to the rule because I have 3 lines. My first equation is y equals 2. Since I already have a y over here, I don't need to double y, so I can just call that 2. My second equation is negative x minus 2. My third equation is x minus 6. So those just came directly from the work I just did to find those linear equations. Now comes the domain. So what I want to ask myself is, for example, for number 2, for what x values does this function exist? And again, you're looking at the x-axis. What I want to ask myself is, what x value does this function start at? And it looks pretty clear that the function starts at -4, when x is equal to -4. So now I want to think, is this going to be for x values greater than or less than -4? Well, this function exists to the left of -4. So it exists for -5, -6, -7, which are all x values less than -4. So this exists for x less than -4. Another hint you could remember is this arrow, as long as x is on the left side, this arrow is going to point in the direction of the function. So this function is pointing left, less than -4. This sign, less than, should also point to the left end of the number line. It's like a little arrow. Okay, so the second equation is going to be a little bit different. It has a starting point and an ending point. So x is going to be between 2 numbers. X is between -4 is the starting place, and it goes all the way to where x is +2. So that's the next important x value in my domain. Okay, so now the one thing I want to look back and ask myself, is this an open inequality or a closed inequality? Meaning, are these open circles or closed circles? And you can see that these are open circles, so maybe make a quick note to yourself. An open circle will lead to a sign that looks like just less than, for example. A closed circle would be less than or equal to. So since these are all open circles, I'm going to be using all open inequalities, but keep in mind if one of these were closed, I would be using a less than or equal to sign at that point where it was closed to show the function does exist at that point. My last equation is for x values, this pink equation. It looks like it starts at the x value of 2, and it points to the right, where it points to x values greater than 6. The function exists for all x values greater than 6. So I'm going to say x values greater than not 6, I'm sorry. All x values greater than +2. This function starts at the x value of 2. Again, you can notice if you think of the inequality sign as an arrow on the number line, this arrow is pointing to the right, or to x values greater than 2. So that's just a way to double check yourself. So my final answer for this problem looks like this. I would also make a note in your study guide that this type of problem, this is going to be the free response question on your quest. So if you want more practice on this type of problem, because you know it's going to be your one free response question, you're going to be given some sort of piecewise function, and you're going to be asked to write a function rule, just like we did in this problem. More practice can be found at 2.3 problem set. The 2.3 problem set, you should complete test corrections for this problem set, problem set corrections for this problem set. I would highly recommend that. The other thing I would recommend is the practice quest. So on the practice quest, there's a problem just like this. I would try covering up that solution and trying that problem on your own, and then checking your answer. All right, one last key concept, also related to piecewise functions, but but just a different type of problem. So in this problem, you're given a function rule, just like the one that we just wrote. And then you're asked to evaluate h of 0. So we know that the 0 is going to be our input. If this helps you to rewrite it as f of 0, to remember that this is your input, that's completely fine. You could replace this with f. It would be the same thing. And then this would be f of x. Okay, so if my input is 0, what is my output going to be? Well, normally in this type of problem, I just plug in 0 for x. But then the question is, okay, so I have two different equations. Do I just plug in x for both of them and get two different answers? Or do I only plug into one equation? How do I know which one? The answer is you only plug into one equation. And you plug into the equation based on the domains over here. So just let's focus in on the domains. We want to think, which domain does our input belong in? Which domain does 0 belong in? So one way to do it is to just plug in 0 to the domain. So I could just say x less than or equal to -2, and then 0 greater than -2. And I want to ask myself which one is true. One of these statements is true and one is false. Is 0 less than or equal to -2? Well, let me think on a number line. If I had 0 here, -2 would be here. So yeah, 0 should be less than -2. That seems like it's true. This other statement, 0 greater than, wait, I just mixed up my number line. 0 is not less than or equal to -2. That is not true, because 0 is to the right of -2. What is true is that 0 is greater than -2. Here on the number line that I drew, you can see that 0 is to the right of -2. Therefore, 0 is greater than -2. Okay, so first statement, false. Second statement, true. Good thing I drew the number line to check myself. Therefore, this first equation is moot. This first equation does not matter because it's not true for the input in question, which is 0. What does matter is the second equation, because my input 0 falls into this category. It's greater than -2. So what I care about is this equation. I'm going to use the equation -x squared plus 4. And then from there, it's just an input-output problem. So I'm going to plug in 0. This just goes to 0. And then my final answer is 4. So we're familiar with this type of problem. The one difference is you have to choose the equation that you're going to use, and you do that by asking yourself which domain is true for your input. And there are lots of problems like this on the practice quest you can go back and look at. All right, that is it for your study guide. Sorry that I had to split this into 2 videos. Good luck studying. Thank you for your attention.